All right. How's everyone doing? Thanks for coming. I want to thank, before I start, I want to thank H2O.ai for hosting this amazing event with their beautiful campus. I want to thank Ganesh and IBM and OpenPOWER for helping to organize it and inviting me. I'm Leo Reiter. So 2 things to know about me. Well, 3 things. First, I'm CTO of Nimbix, CTO Technology Officer of Nimbix. And I'm responsible for technology strategy and product development at Nimbix. And there's 2 other things to know about me. First, I'm a technologist, not a scientist, which means my job is to design and enable human beings to actually use technology, including scientists. Thank you. All right. And the second thing to know about me is that I'm from Texas. So believe it or not, we do have a lot of technology out there, so I'm hoping I can share some of it with you today. So a little bit about Nimbix before I start. We've been around since 2010. We're headquartered in Dallas, but we actually have customers in 68 countries, and we also have customers in the Bay Area, actually quite a few of them. So in 2016, we actually partnered with IBM to bring the IBM Minsky system to the public cloud. And actually just coming here in a few weeks, we're going to be extending the IBM Cloud to deliver Power 9 on demand as well. And IBM likes us a lot, and they call us a top strategic service provider in 2017. So the reason that Nimbix exists is very simple. So there's 2, very big market dynamics that we're headed for a collision course. First would be the end of Moore's law, at least in terms of scale-up systems or single systems. The second would be that the amount of data to process, both in terms of size, frequency, structure, everything, was just growing insanely large and fast, right? So obviously, if you don't have compute that can keep up with your data, something actually has to give. And we looked around, and there was really no good platform out there to address all this in a pretty reasonable way. So along comes Nimbix, and we basically have 3 principles that we kind of built our technology on. The first is acceleration, accelerated compute, such as GPUs, FPGAs, DSPs, you name it. Anything that's not a CPU that's actually designed to do a kind of a subset of what a CPU does, but really fast, right? Or at large scale. The second would be HPC, or high performance computing, and there's reasons that we'll get into why that architecture actually makes a lot of sense for things like AI. And the third one would be containers, particularly Linux containers running on bare metal. And obviously, at the time Nimbix was founded, cloud computing was starting to emerge. And in order to democratize this technology, we decided to offer this as a self-service, on-demand product. So what that actually enabled were 2 things, right? First would be the actual scale-out economics, and the second thing would be cognitive insights. And that actually came from the same technology stack. And what that does is enable use cases ranging from simulation, oil and gas, media and entertainment like rendering, obviously life sciences, machine learning, and data science, which may be able to be used interchangeably as well. So before I continue, I got a question at IBM Think last week when I was presenting presentations somewhat similar to this one. After I was done, somebody stood up, and the first question was, what's a Minsky? So I figured, all right, I'll tell you in advance this time, so I don't have to go through the whole thing, and because I mentioned that word. So basically, it's IBM's S822LC, which was the Power 8 dual Power 8 CPU with NVIDIA P100s. They called that the Minsky when it came out, and now it's been succeeded by the AC922 for HPC and AI, and that's actually got 2 Power 9 GPUs. The faster version of NVLink, as Ganesh mentioned earlier, and 4 or 6 V100 GPUs. And actually, it's the same HPC node that Oak Ridge Summit has. You can actually get on the Nimbix Cloud. Now, currently, we have the 4 GPU one, not the 6 GPU one, but other than that, they're identical to what is actually being deployed in a national lab. So what does this actually mean to human beings? Well, it just means linear scale with insane bandwidth and very low latency. And I have a thing there where it says, just slide right to scale on the Nimbix Cloud. So we'll get into our user interface a little bit later. And the next thing is, well, what does HPC actually have to do with AI? So people think there's actually a huge distinction between the 2, and there is. Traditionally architected, there are differences. But we're actually seeing a lot of convergence, particularly because, and actually IBM has done this recently. There's a lot of benefits to tightly coupling scale-out training, for example. So if you can get a lot of GPUs to work together over low latency fabrics with tight coupling, you can do some amazing things with deep learning training. And you can look up all the performance numbers from IBM on this, what they call distributed deep learning. And we'll talk more about that later. So I'll do the obligatory AI explanation in just 5 quick points. So what it is, it's basically compute that just recognizes input, categorizes or classifies it, and responds with an action, such as a recommendation or prediction or whatever it might be. How it happens, there's training, learning, and then there's inference or recommendation, generally speaking. That's deep learning focused, but that's pretty much what I'm going to focus on today. Why is it big now? Well, because again, the data sizes keep getting bigger, the scope of the data, the speed and frequency that is coming in, and the variability of the data, as well as the structure, keeps changing. So it's a great time to actually start using these algorithms versus trying to process it using traditional methods. What for? Everything from recommending products to recognizing handwriting to directing self-driving cars, right? We've heard some pretty great content on that. And quite frankly, as a cloud service provider, I'll shamelessly say that cloud is a very powerful enablement platform for AI, and we truly believe that. The other thing I wanted to cover is the difference between strong AI and weak AI. So strong AI is the dystopian stuff that's going to come back and kill us, and that's, you know, pretty awesome, but for now, it's probably best to leave to the futurists and to Hollywood. So the weak AI, or what we're calling narrow AI, is actually what, at least to me, because of the practical application of it, is much more interesting right now. And this is really about focusing on topic and ability. It's not about intelligence or self-awareness or creativity. It's about solving predefined problems using algorithms and data and compute, right? And that must be some kind of joke because self-driving cars don't hit people. Or do they? Okay. So, and it's not just us thinking it. I mean, Gartner obviously came out with their top 10 strategic technology trends for 2018. They said AI foundations, specifically narrow AI, right on the map of the top 10 things. The other thing that I'll mention that's really not, it's a bit tangential, but it's important, is about intelligent apps and analytics built into platforms as well. So one example I use is our cloud platform actually produces a tremendous amount of data, not the data that you feed into it. I mean, we're not like other clouds that actually like look at your data and sell it. We're talking about the usage data, right? When you actually go in and do something, we know that somebody ran this application with this size data set for this long, right? Things like that. So building analytics into platforms can do things like when you go to launch something in the cloud, it could say, you know what, we think that you might actually get better economics if you just did it this way instead, right? Those are the kinds of things that, that these platforms can actually start by learning. And that's about taking the usage data and just feeding it into models and algorithms to actually get these results without having to really ever open up what the actual data you're feeding your own workloads. Okay, so what's so good about narrow AI? Let's see if we can cover it really quick. First, it won't hunt us down from the future. Second, it probably won't kill the crew to save the mission, quote unquote. Third, it probably won't enslave us in a simulation to harvest us for energy, we hope. But most importantly, it's not here to replace human beings. Now, what it will do, and we've heard a lot about this already, probably articulated much more eloquently than I can, but we think it's going to unleash human innovation, and it's going to do it, in my opinion, it's going to do it in 3 ways. First, it's going to augment our abilities to automate the mundane while letting us focus on higher order stuff. It's going to make our daily lives easier. In other words, if it can process data for us and then recommend what we should do about it, it lets us do other things or just have maybe relax every once in a while. And finally, it's about making our lives safer. So we can already see things like using computer vision to identify safety violations or safety concerns, like in a construction site if somebody's not wearing their hard hat, things of that nature. It can take careful action quickly, right? And the thing that I like to say is that machines fail, generally speaking, when they break, whereas humans actually fail all the time. We fail, we're not actually broken and we fail, right? So we can hope that if we can actually get some automation on the things that are not necessarily higher order things that we do, that we'll see a lot less failure in the world as kind of a long-term thing. And I actually wrote an essay about this, if you just go to leoreiter.com if you want to read it. So moving on to the actual technology. So as far as, we talked about democratizing these capabilities. So it wouldn't be democracy without choice. So you see all these rival architectures here, obviously. These guys are all competitors, but they're available. These platforms are actually available in our cloud on demand, right? So again, we think the IBM Power with PowerAI, from a vertically integrated perspective, software, hardware, bandwidth, et cetera, is a great choice for scale-out training. But you may want to do some things on x86 with more, lots of GPUs. The NVIDIA DGX is a great platform for that, and their optimized software catalog. For whatever reason, you may want to do some CPU-only stuff, in which case you have that capability as well. And then FPGAs, really interesting to Nimbix. We have a great partnership with Xilinx. And there's a lot of stuff that you can do on FPGAs, especially when it comes to low latency and real-time stuff that, obviously you wouldn't train a neural network with an FPGA, but you might plug it into a video camera and identify objects using a trained model, right? That's kind of the thing that they're good at. And then you can get the tools from Xilinx as well as the educational material and all that on demand as well. So in short, we say you can build the future end to end. So maybe here's an example of where you would actually do your training using entirely in cloud GPUs, but you would actually test your inference on cloud FPGAs and you would deploy the inference on the edge, right? As actually like programming into the gates. So the edge, in this case, maybe a self-driving car, maybe a mobile phone, maybe some sensor, whatever, right? As far as the software goes, including H2O stuff, we also have IBM stuff, a lot of NVIDIA stuff. This is all about software for AI specifically. You could also find software for simulation and other stuff in our cloud. But the bottom line is that you've got here about 24 turnkey workflows, and they're all extensible with push-to-compute, which is what the technology we call for continuous integration of containerized applications. So if you can write a Docker file, you can customize any of these workflows or build a new one in minutes, right? So back to PowerAI specifically, which is the subject of my presentation here. About 3/4 of the way done, and I finally mentioned a lot about PowerAI. So, so the idea is that, again, IBM systems, we think, the power systems are actually vertically integrated in the sense that they have the high bandwidth memory bus for the GPUs, and they have the GPUs and the very fast processors and large memory and so forth, with the software that's actually optimized to take advantage of this as well as scale out. So that's what the PowerAI does. And our cloud is actually vertically integrated all the way down to the data center floor. So you've got native InfiniBand fabric, you've got bare metal everywhere, there's no virtualization. So when you marry these two things together, you end up with what we call the no compromise combination for AI, especially when you're scaling out. On the technology front, specifically on the PowerAI, you've got effectively the IBM architecture. Again, it's the NVLink. The issue is keeping the GPUs fed, the GPU memory fed, right? So if it takes too long to copy it out of the CPU, what you end up seeing is underutilized GPUs. And if you're paying by the hour for GPUs, you're losing money. And I can't tell you how many times I've seen GPU utilization under 50%. I mean, that's just unacceptable given the pricing you're paying for GPU access. So the idea with these systems is that you can actually keep feeding them data and keep the GPUs loaded the whole time. Distributed deep learning, again, built into PowerAI. So what they've actually done is this is where the HPC comes in. They've actually created a scale out or a tightly coupled scale out architecture. So they effectively built MPI underneath TensorFlow to where it's completely transparent. So instead of having to worry about parameter servers and whatnot, you just basically do things as if you were doing it on a single system. And with the DDL, it'll actually scale out to all these different machines in parallel instead of distributed. And because of the InfiniBand that you get in our cloud, for instance, it's a low latency interconnect between the machines, so it doesn't actually introduce any bottlenecks. And then Jarvis is actually our cloud operating system. It's called Jarvis. And it runs on bare metal. There's no overhead. It runs at native speed. So there's actually no hypervisor to get in the way of anything. So we actually containerize workflows on our cloud to achieve that level of agility. On the actual supercomputing performance that you get, if you look at the way that our cloud is architected, this is actually a picture of one of our racks in one of our data centers. And you'll see basically a lot of InfiniBand, obviously, high density, pretty state-of-the-art cooling, et cetera. But it's really designed for scale and for scale out and for low latency across racks and so forth, right? There's a very extensive fabric that we've built together with Mellanox to achieve this. So it's actually not that different from what Summit has deployed, what Oak Ridge has deployed for Summit. It's an EDR spine with FDR to the machines. Actually, the IBM machines have EDR going to them as well. So you've got 100 gigabit low latency InfiniBand going to each node. The containers run on bare metal. And the GPUs also talk to each other across the machines using things like GPU Direct RDMA and so forth. So it's all about eliminating latency and increasing bandwidth. That's the bottom line with getting performance out of these things. And then finally, what would a cloud be if it wasn't actually extensible? And we do that through containerization. So we have lots of Docker-based images. We have open source tools in GitHub that you can extend or download or use as is. There's a developer community. We've got documentation and examples, and by the way, so does IBM on our cloud. And we also provide continuous integration, continuous deployment for the IBM Power systems. So if you wanted to compile code on Power and you don't actually have a machine that you have access to compile code on, you can just do it by committing code to GitHub and just telling our platform to compile it. And what you're seeing here is actually, the workflow is that the repository is cloned from GitHub, it's compiled in line, and then it's pushed to Docker Hub or whatever Docker registry you want. So you own the code, you own the container, but you can use our systems to compile code on. You don't get charged by the hour to compile code either. It's just part of the service that we offer. On the actual turnkey tools that we have, so there's different phases to AI work. So you may be doing research or analysis. You may want to use a Jupyter Notebook for that. If you wanted to do some more intensive development or test out distributed deep learning, you can actually get access to the operating system directly that's running in the container, any flavor you want. And finally, if you wanted to extend, again, this is our push to compute workflow, where it's really good for custom workflows that you can either use privately or share with your team, or like, for example, what H2O.ai does, they deploy their applications on our cloud as an ISV. So you can actually go and use their applications from the marketplace, and they run turnkey as if we had built it. So who's using this stuff? So I'll tell you about some of our customers and what they're achieving. So first would be this Oregon State University's Center for Genome Research and Biocomputing. What they're basically doing is collecting water column images and trying to determine, based on the species of plankton they see, ocean temperature and salinity, which is part of climate change studies, right? So the big challenge is that they have, they send a ship out to sea every week. It collects 100 terabytes of data. Obviously, you can't just ship that to the cloud. You can ship it to the cloud if you want. It's not easy. So what they did is they put a Minsky, there's that term again, on the ship, and to pre-process the images to basically throw out what's automatically not interesting. And that gets it down to about 3 terabytes, which is much more manageable. They pushed that up to the cloud. So we call that a cloud-to-edge architecture. So there's actually some processing at the edge, there's processing in the cloud, and then the results are given back to whoever's looking at them. And what they were able to get is, in a nutshell, 10 times faster processing than on other clouds. One of the main reasons is they were able to use significantly more scale without the bottlenecks by using distributed deep learning. And with the modern containerized deployment, they didn't have to actually cloud enable their apps. They were already containerized, so they simply just deployed them, right? So we realize that not all applications are containerized these days, but more and more applications are containerized these days. That's just kind of a fact. So that works out really well. Another use case that we see, a company we're working with called the Caucus. So they're actually in Middle East and Africa, so Dubai and North Africa. And they're doing things like putting cameras in taxis and delivery vehicles to actually study the driver to make sure they're not falling asleep or that they're looking at the road, et cetera. I think might be very interesting for you as well. And then also, the same technology can be used to detect human trafficking in Libya. So for example, somebody gets into the back of a car, the camera can be looking there and kind of look for patterns to see if they're, there against their will or not, right? So things of that nature. So really interesting technology, again, designed to make us safer. It is, you could argue it's a bit of a surveillance culture thing, but on the other hand, if used correctly, these are the kinds of things that could actually make us safer as a society, right? Some others, the one that Down here is the NIH. It's actually using our cloud to do automated diagnostics. But then we have a couple of other customers doing, speech recognition for call centers, as well as training, teaching AI courses and so forth using our systems. And then this example is actually developed by one of Ganesh's team members. It's about identifying non-performing assets in the Indian banking market. And it basically highlights data preparation, deep learning frameworks, design of the network, as well as accuracy and training. And there's actually a video, so how are we doing on time? We're good? All right. So they've done this pretty awesome video that we're going to, I'm going to start with the volume low just in case. Go. The music really adds to it, so hopefully you can hear it. So this is actually done on the Nimbix Cloud and using a lot of open source as well as Jupyter notebooks. So it's a pretty interesting course material. That's actually our cloud platform user interface. So actually, Ganeshan tells me that they've got about 20 or 25 other use cases that are being developed by the same organization. So we should be seeing a lot more of these studies where you can also download the data yourself and play with it, but it's just great material. That's in our cloud, yeah. So actually, IBM has on DeveloperWorks. They actually offer free access to the Nimbix Cloud, both for Vision as well as for the Jupyter notebooks. So actually, we'll get to that in a minute. So they offer packages of free compute time on the Nimbix Cloud to actually, as well as educational material to get people on board. So what I found really interesting about this is that, so this was actually a very contextual use case for AI. There was a recent scandal, and it played really well when somebody actually sat down and actually built a model to do this. So it's a real world thing that, I mean, most people can understand. I wouldn't say anybody can, but certainly anybody who knows anything about finance can. And it's not just an academic exercise, right? So it's a real world thing that people can look at.
There are a lot of banks right now talking to us about implementing this solution exponentially. But we use only your 100,000 data, like 100,000 records for other people. But some banks really wanted to work with us and and asking us to use their millions of people data actually. So when we have more data, definitely we need a more powerful system too, and that's why the Power 9's kind of the unveiling system will be very useful.
The other thing too that as far as cloud platforms go, based on their on-demand access to where you don't have to buy all the hardware full time to actually do your stuff. So as you pointed out, if you wanted to do a very lengthy training, you could actually reduce the training time or increase the accuracy by scaling out the systems. But then when it comes down to testing and inference, you can actually use much less compute. So that's a way to kind of right-size the infrastructure in real time for whatever it is that you're actually doing. which is a little bit more difficult when you have to buy the infrastructure ahead of time to do it.
So this code is also open source. Actually, I can share it with you all, and also we put it in GitHub. Actually, this code you can go and take a look at it.
So I think what that window just showed, showing the GPU output there, this is actually you don't have to pay for a 4 GPU system. We actually have 1 GPU systems that you can use. They're basically they're fractional when it comes to AI. So if you don't need 4 GPUs, you can use 1, right? It's obviously less cost. How many people here actually use Jupyter notebooks? Cool. Yeah, it's a great format for sharing too, or peer review for that matter, right? Because you don't have to, you used to have to tell people how to replicate what you did and then wait for them to do it. Now you can just hand them a file and they can just click play, right?
Most of the training that is being done in data science, actually they do it in Jupyter Notebook and make us kind of do that.
Right. Yeah. Okay, so that's the end of that video. So hopefully, like I said, Ganeshan has we'll get you the GitHub repos and so forth for the code. One thing I want to say too is that, we just announced, actually IBM just announced the extension, effectively Power 9 in the IBM Cloud. Well, that's actually running in the Nimbix Cloud. We've actually extended the IBM Cloud. We're starting in the US South region early in Q2. But we're going to expand globally, and there's 2 great things about it. One is you can use your IBM account if you have an IBM Cloud account, and 2, if you actually have if you have storage in the IBM Cloud, there's no transfer fees to actually get it running into the compute. Even though it's technically on a separate infrastructure, we've taken care of that transfer so that the end user doesn't actually pay for data transfer. All right, the one thing I wanted to point out here, first of all, thank you very much, but is that IBM, if you go to this link, and we can probably bring it up, but you can actually get free time on the Nimbix Cloud, either for vision or for just straight PowerAI for doing whatever frameworks you wanted to do for some period of time. So that's, IBM makes that available, so we thank IBM for that. So did anyone have any questions? I can probably show, I don't know if we have time for maybe showing.
Maybe a couple of questions.
Yeah.
Right now.
Yes, sir.
What is it about FPGAs that makes them suitable for inference but not training?
As I understand it, it has to do with memory primarily, and also precision on the precision. So one thing that's happening is like there's reduced precision for inference is actually really powerful. It's this research being done now. But really, if you look at the GPUs, they have huge amounts of memory, so you can actually load the model data and so forth. And it's just much more suited for training than an FPGA.
Any more questions for Leo? Okay, let's give him a. Okay.
Yes.
Why vision? You said you mentioned vision as a very important use case in your presentation. Mm-hmm. Is there anything in terms of your data size or something that lends itself to this cloud?
So the main thing is that IBM has actually deployed PowerAI Vision on our cloud. So it's a great application for self-tagging videos and then using reinforcement learning. So it's popular for that. But the other thing obviously is the amount of data that when you process video is very significant. So again, having high, large memory sizes, high bandwidth, as well as GPUs with lots of memory on them, is definitely a thing that we bring to the table.
Do you have anything with speech? I heard Professor Andrew Nick talk about training an AI for speech recognition, that in 5 years of speech volume and transcript.
Right. Right.
It's huge volume. So have you seen anything?
Off the top of my head, well, we do have one customer who's using speech recognition in a call center type application. Mainly as the platform provider. We provide all the frameworks, we provide all the GPUs, so we have customers building workflows on that. I can't think off the top of my head of a speech application that you can just run turnkey, but certainly we have customers, doing speech.
Okay, let's give a round of applause to Leo, the CTO of Nimbix. So, as part of the demo, whatever Leo showed, there is an extension to it. We have nearly 24 applications. We have been working with many people worldwide. To develop on top of the Nimbix platform using PowerAI. And if you guys wanted to share some of your case studies, where you want to work with us, we do have some good, the data scientists, who can also help us to put together an algorithm for kind of, some kind of problems too. So reach me out, and certainly, I will help you. I can give you a platform, for you to work on and get onto the PowerAI development, arena.